Alright, so everybody can hear me clearly. I guess the ones in class, you can review back this recording. But today we are going to complete what you did not last week, a few days ago only, right? Monday, Monday, So we did something on Monday. So we were doing this one, We were doing something on hydraulic lifting mechanism. As you can see here, page up, enable editing. Okay, now I can draw things. If you can see here, so this is in collapse mode. So this is the minimum height, and this would be a reference when you have a maximum height. So this is minimum and this is maximum. So I believe you guys have assembled everything together. So you have got yourself a working scissor lift mechanism. So altogether there are a lot of parts involved. And basically you're going to get something like this. You're going to get this crisscross scissor mechanism. And you're going to be assembling this crossbar. So this crossbar here, and then basically this is the lower part besides the platform. And then we're gonna need to be answering a few questions. So let's take a look at our questions now. Number one, so we have done this assembly of the lifting mechanism. So hopefully everybody has been able to do this. So this one is okay lah. So next, let's check for interference. So this thing is a must. So you must do this. Must be done always in assembly mode. So you don't want anything to be interfering with each other. So if you have parts clashing, that is a bad problem. So you don't want your parts to be clashing. Okay. So let's do that. So let's open up your SolidWorks. Hopefully you guys can open this up. And let's check. Number one, I'm going to check in the highest possible configuration. Maybe something like this. This is too much, So if you notice here, this thing is going so high up. It's actually being guided by this thing this rail, this slot. When this thing goes to the maximum position, and then this will be at the highest point. So the highest point is controlled at the bottom most likely. Because if you look here, if the bottom part is already at the maximum side, maybe clash with this one. This thing still have some clearance, You still have some clearance here. So you cannot push this one If you go up to this level, I think the bottom part will clash already. See? So you have clashing already. So the maximum height is controlled by the bottom part So how do you make sure this thing is meeting that one? Maybe you add one more assembly, mate. Touch the surface Touch the surface and touch this line. This become coincidence. But then you know this is coincidence, right? But then you just have to X. Oh, if you X, it doesn't go back. You have to accept also. So again mate, this line goes to this line, and then just click accept. So once you've clicked accept, there is something called a mate here I think concentric code. Now this one, you cannot have this mate here. If you have this mate here, your assembly will not move. So this one you have to right click and delete. So you just want to check what happens when this thing is at the highest point. If you look clearly here, open up the eyes, no, this one, open up hidden lines. So you're gonna see something like this lah. So this is the most highest position. Okay. So now what cuba buat tengok. So you guys are gonna have to do it on your own. I'll set a timer to 1 minute. Do at your own model, don't look at me. Can you guys get this thing done? The bottom part. Make it concentric. And then you're gonna get yourself at the highest point. Boleh kah?
Boleh.
So dah siap kah?
Saya dah assemble, cuma nak tu lah.
Cuba bagi dia maximum tengok. Highest point. Did everybody get highest point? Assembly I believe everybody can do lah. So highest point, let's go to evaluate. Click here, evaluate. Choose something called interference detection. This one. Click on it, click. And then the whole model will be rectangle, right? So the whole model is being assembled. Click on calculate. So if you click on calculate, it's going to show you if there is any problem with your model. Apparently I have a problem with my model. There are some interference. See, I didn't assemble it properly. You have a thin gap here which is clashing. See, I have a gap here, and then this thing has gone inside this one. Okay, so at any point I think this thing will be interfering lah. Interference detection, calculate. There's a problem there. So do you guys have any problem with interference, or it's only me?
Tak ada interference.
Tak ada interference So then you guys are better than me lah. Apparently I have one small interference here. Yang ni ada gap kan? Can you see this gap? This small gap. This one is protruding inside lah. But for the time being
saya cuba saya tengok dekat bahagian bawah. Dekat bukan saya putar sikit.
Terlebih dah ni.
Sebab saya nak tengok sikit. Pusing sikit, pusing lagi. Sebelah kanan.
Sebelah kanan. Something like this lah. Interference again. Same thing. No interference pula. Tadi dia extra dah kot. Sebab dia dah clashing tadi. Okay. So apparently sometimes you don't have to delete the mate, you just have to suppress the mate. I'm going to suppress. Go to assembly, mate, this point to this corner. Click on accept. This will be at the maximum height. However, if I want to disable this one, right click, I just click on suppress. Okay, so let's measure what is the height. So choose evaluate and then click on measure. So you can choose the top platform to the bottom at the base. Boleh lah. Berapa dapat? I am getting 6618.95. How much are you guys getting? Draw maximum 6618 mm. So take a note of that. Take a note of yours lah. So next I'm going to put it down.
Daripada bawah sampai atas macam mana?
Daripada bawah sampai tempat orang tu pijak lah. Right? That would make sense lah. Kalau on top of the railing, that does not make sense lah. Bottom of the plate, bottom of the platform to the platform punya plate tu. 6618. So once you've done that, have you guys done that? Hopefully you guys have done that. Go here, go to the right hand side. There is something called create sensor. So click on that. Click on create sensor. So once you click on create sensor, there is something will come out. It will go automatically to measurement lah, because just now you were measuring, right? So choose this one, distance 6618. Okay, boleh ya? Click on accept. So you have yourself a sensor lah. Mana sensor saya hilang? Kalau tak ada sensor lagi, click again. Sensor. Mass properties change to dimension. Oh, ni susah sikit. Betul kita buat tadi. Measure top plate to the bottom plate. And then choose sensor. Choose this distance. There's a choice here if you want to create an alert, if it's greater or lower. But for current case, I don't think we need to do this. Click on here, accept. So dia keluar tak sensor kat sini? Dah ada dua ni. See, I've got 2 sensor here already. So I can delete one lah. So this sensor can help you lah. You don't have to measure all the time. So now if I move it down, if I move it in the middle, I just have to go to sensor and then I click on update. So it will update lah. My current position is at 5 meter. Just now this thing can go 6 meter, very high. If I go down some more. Now it is going to be controlled by this end lah. I think this thing will clash first. There, cannot go anymore. If I go slightly further down, this thing will crash lah. If you can see here, if I go down and more, if I go slightly down like this, collapse all the way down. Do you guys get something like this? Patutnya dia flat macam ni lah kan? You see, right? If you take a look at our original model, in collapse condition, it should be like this. all the way flat. All those beams they are flat. But currently we have some problem lah. This thing will just clash. It's supposed to go like that. But if I do like this now, if I click on interference detection and you click on calculate, it's going to it's going to tell me I have some problems lah. I think this thing clash. Ini pun ini clash tak all the way end. Dia dah clash tu. Again, you can do the same trick lah. Go to assembly, click on mate, this line to this line. Bukan paralel lah, concentric. Tak berjalan lah. Dia tak berjalan. This is obviously in clashing mode already, right? If you see properly, if you open up this view, cannot see this view cannot see anything. The whole thing platform display state.
Dia bukan masalah assembly ni.
Ini maybe design problem already lah. Okay. This platform. Go back here. Something like this is already some sort of design problem lah. So by right, you have to modify lah all this. You don't want this to clash, right? But by right, kita nak design dia in such a way that all these blue arms kan, dia patutnya flat macam tu lah. By right. So we acknowledge lah we have this problem. So these are the things that you can modify before you do any prototyping or modification. You're modifying your current design lah. Okay, so if this one, if you were to design, you have to elongate a bit lah. Make this thing a little bit longer. Create some more clearance. You know how to do it. You can open up this part and then elongate this part a little bit longer, and then this part also have to go in slightly more. Okay, you can modify there. So what else can we do here? Can we update some sensor? So if it's in a bottommost position, saya rasa kalau betul-betul nak tahu dia bottom kan, I think you have to mate again lah. Mate, what happens when this bottom plate touching to this plate? This is the most bottom position lah. In this condition, cuba klik interference detection, calculate. So many interference. Ini 1, ini 3, ini 4. Make sure kamu ada berapa interference. Cuba calculate tengok. Cuba flatten the platform. If you flatten the platform, how many interference do you have? Berjaya tak? So by right, kamu kena buat ni semua ni. 1, 2, 3, 4. Patutnya
saya pun 4 agak interference.
4 sama So by right nanti dah kerja, kamu kena perbetulkan semua ni. Interference ni tak boleh ada langsung. Tidak pasang parts, kamu memang crash lah.
Jadi kalau jadi sekarang ni saya nak kena betulkan design ni lah.
For the time being, nantilah
Okay, saya teruskan.
kita settlekan motion analysis semua dulu lah. So by right, you have to settle this one lah. Mana boleh macam ni kan? Ni clash ni, tengok tu. Berapa banyak dia clash? That much lah. Memang berapa kita kena ubah ni ya? Bolehkah kita check? Tak boleh no. Interference, they will give you volume lah normally.
Tapi kalau saya guna measure daripada hujung sana ke bulat tu boleh ke?
Dia tak boleh measure. Boleh juga. Yes, you can do that. And then you have to minus lah. Right, you can minus.
Macam yang apa tu?
Measure this n to this n. Dia the center point lah.
Dia bagi center point.
Total
ke saya buat macam ni ke saya nak mudah saya buat macam ni. Yang tu ambil, lepas tu ambil diameter dekat tengah tu, lepas tu saya bagi 2. Ambilkan dia punya radius, lepas tu tambah lah.
Itulah, kamu kena tambah and measure lah. Dia patut ada some sort of clearance lah. Tak boleh dia clash terus kan. So by right you can open up the platform lah. Open up the platform. You know lah this one. You have to cut here. Control 8. And then you have to extend some lines. And then extend some lines. Trim some entities. And then ataupun nak mudah,
kalau
put a circle lah in the middle. Tak boleh lah this one.
Kalau saya ubah dia punya jarak tu je.
I think easiest lah.
Saya apa tu kan dah apa tu
ini,
dah
pakai ni je, offset entities. Offset tak boleh no.
Tak, maksud saya
convert entities. Accept and then kita move. Cannot lah, this entity cannot be moved. Tengoklah radius dia berapa. 35mm. Shift by, let's say 20mm. Dimension this line to this line. Ya. And then put a circle of 35. Accept and then extend the lines. Take some time lah, by right kamu kena buat lah semua ni. So I've got that thing, and then I can do this one lah. Exit sketch, extrude cut, through all both. Sketch contains unsuitable geometry. Ada apa? Ada 2 line kot ni. Should be okay. Extrude cut to all both. Open contour, maksud dia tak close lah. Ni ada some sort of gap. Trim entities. This is the problem lah. Ini, potong ni. This is my problem. Trim this line. Accept. Exit sketch. Extrude cut. Click on sketch first. Extrude cut. Through all for both. So I have extended there lah. Tapi ni patutnya kena tambah sikit lagi lah ni. Takut dia nipis sangat ni. Right? By right you have to extend this a bit lah. So you have to go back to your assembly. Model has been changed. Rebuild. Yes, you must rebuild lah. So now you can check again. Do you have the same problem? Check on interference. Ada lagi ada sikit lagi I have some small interference here. Not like previous time lah. So things like that lah. So always be careful when you're doing assembly. Don't forget to do interference analysis. Okay. So now I can suppress this one, so that my model can move. Again, there's this convenient lah. You have a sensor here. Update. So minimum distance from the bottom is 1581. Boleh 1581. So you have learned how to do these things assembly everything done. Check for interference, very important. Modify if you must to remove any interference. So minimum height sudah dapat 1581 for me, maximum is 6618. Yeah, and you have learned how to use sensor. So we have done up to number 1 and number 2. Now we're moving to number 3. So I'm gonna wait a few minutes. Make sure you guys can do your work. Okay, next. Boleh ke next? Do you need more time? I guess next is we are going to determine the weight of the total lifting mechanism. In this case, since we are lifting everything, so what is the weight? Boleh kah kira? What is the weight? Base platform 3, 4. Cross arm. So we've talked about this before. Mass properties. Ini I'm getting some data in grams. 19.433 gram. So wah, dekat 2 tan ni. So heavy, yeah. So again, if you don't like the measurements in gram, you can change here. Edit document units. You can change mass from gram. You have to click on customer. Click on custom, go to mass. From gram change to kilogram. Click on OK. Measure again, mass properties. So you're getting this one lah, 1928 kilograms. But this one is for the whole thing You have to minus the platform This base, what is the mass of the base? 130. Berat betul Did I choose the correct material? Material is not specified. Did we assign material? No. Then how do you know what is the weight? In order to calculate the weight properly, you guys have to assign material. For example, the base. Assign material. Edit material. Change it to steel. If you have more correct value, you can choose maybe you can just choose plain carbon steel. Apply. Click on close. Everything you have to assign. How to assign everything in the material? Or do you have to go one by one? You might have to go one by one Material, plain carbon steel. Material. Okay, plain carbon steel. Everything has been assigned Did I get the material correct? Platform. Make sure change to plain carbon steel. Base dah betul, platform atas dah betul. And then all your parts all the cross arm change the material. Okay, I think done everything already. Cross arm bottom, plain carbon steel. So put everything put all the materials as plain carbon steel. Yeah, plain carbon steel. Everything is plain carbon steel. Okay lah, done. Okay, so now let's measure the whole thing again. What is the weight that you are getting? Control A, mass properties. Unable to compute. Mass properties 2813 beratnya. Kamu dapat berapa? Assign properly lah. Tapi all this mass it is not inside your calculation unless you define gravity. If you define gravity, then only it will be taken care. It will be taken as mass lah. If you don't put gravity in your analysis, nothing happens to the mass. You must have gravity. You must have acceleration.
So yang lift tu
Aha.
apa tu bukan yang atas ni saja ke?
Platform.
Platform saja tu.
Betul platform, tapi saya rasa yang arm tu sekali. Tapi yang bawah platform tu tak ada lah. The base is not involved lah. So you have to minus the base. Base ni tengok berapa berat dia. Base berat dia saya dapat 1 tan ni. Berat gila kan? Brace tu sampai 1 tan. Mesti dia design solid ni. Solid ke? Hollow tu. Nampak tak internal dia? Thickness tu. Tapi berat sangat lah. 1 tan macam mana ni? This is so big kah? Measure this to this. 3 meter. 3 meter. Okay, so that's the thing lah. The bottom platform not involved. Cuma platform dengan kamu punya crisscross. Okay. In your beam lah. Kalau kamu tak mau buat macam mana, hide. Can you hide component? Control A, mesh properties. 1798. Dapat tak kamu punya? If you assign properly, you will get lah. Because I hide the bottom base. If I open up the bottom base, I click Control A, mesh properties, dia naik balik lah 2813. Okay, so check yours. Make sure you calculate without the base lah. This base, hide. These are the things that you have to push. Ini semuanya kamu punya hydraulic cylinder nak push. Boleh lah? Open up. This thing plain carbon steel, betul lah. Cross arm is one part only. Okay ah. So okay. If I'm mistaken, you have to let me know. So currently I'm getting 1798. So over here I have two things lah. I have the structure load. Structure load is already 1798 kilo. And the payload, I want to put 500 kilo. So payload 500 kilo probably can withstand 5 people lah. Or maybe 2 people plus what are the materials they put inside, right? So that's why the design for in this case lah, I put 500. So if you add together, you're gonna get about campur 1798 plus 500, 2.3 tons. 2298 2298 kilo. Oh, this much lah. 2298 kilo. So next thing, there are two ways to do this lah. Number one, during motion analysis, you have to put gravity. Can also. Or if you don't want to put gravity, you just have to Kamu kena letak force lah kat sini. Again, change right. Okay, one more thing I think we are almost at the end of this lah. We are no more in modifying mode. You wanna analyze the motion. So kalau nak analyze motion, katalah saya nak analyze dia dalam keadaan at the bottom. Ini I can unsuppress, lepas tu suppress balik. Dia duduklah bawah balik kan. So let's say like this.
So yang bawah tu perlu saya tarikkan.
Kalau kamu ada mid yang kat sini kan,
Okay.
I suppress and unsuppress. If I unsuppress this one, it will be highest point.
Okay.
If I suppress here and I unsuppress the bottom, it will go down. You can play lah with this. It's like activate and non-activate certain mids. Nak tengok dia naik atau turun kan.
Tapi tak perlu nak ubah lah yang tu apa ni. Ya.
Ini view control aja lah. This is just a view control.
Tak yang apa tu, yang design dekat dalam tu sketch.
Design dalam sketch. Patutnya kamu ubah lah. Interference punya problem tu lah kena settle patutnya.
Oh, jadi kalau dah nak buat report ni, saya kena clearkan lah.
By right lah. It's very easy, right? Just now I did one lah, but I still have some very small interference left out. But don't let that stop us. So let's continue. Again, if I go on motion study now, it will capture my previous condition. If I don't want this, I just right click, create a new motion study. It will capture my current one. So motion study 1, I can delete lah if I don't want this. I'm just looking at motion study 2. So it kind of remember my last position. So again, turn on SolidWorks motion. Change to motion analysis. Next kita nak gerakkan dia lah. So but then we want to simulate this 2.298 payload. 2298 payload. Macam mana nak buat? You have to apply gravity. If you don't want to apply gravity, you just have to put a force here lah. Put a force. Dekat mana? Dekat sini. Different direction. Okay, and then put the value lah. 2298 kilogram kan. So 2298 times 9.81. It's going to be, tekan kat sini pun boleh, times 9.81. 22543.4 Newton. So accept. So I've got a force. What is my force? It is the force of 2.3 ton lah. Ataupun ya 2298 2.3 tons. If you don't want force, simulate gravity. Remember, I think last Monday we simulate gravity using this Apple icon here, gravity. There are two ways to do it lah. Okay, I'll wait for you guys. Lepas tu baru kita nak check how much force is required to move the thing. Okay, done. Everybody okay? If you guys are okay, we are going to put this one, motor. Click on a motor, change from rotary motor to linear motor. Now you have to decide lah. How are you going to move this thing? What is the smartest way to put force in order to lift this thing up? There are so many ways to do it. Right. Cuba cari idea. Kamu nak tolak benda apa? So just imagine you have a hydraulic cylinder. If you have this hydraulic cylinder, this one lah. Where are you going to put this thing? Right, this hydraulic cylinder. Take a look at the original one. Ni. This hydraulic cylinder, the one that you learn in pneumatics and hydraulics. Right. You get inlet and outlet. Fluid pressure, right? You've got pump providing pressure for your hydraulic cylinder. This is the thing lah that you want to put inside your design. So where is the best location? Siapa ada idea? Paling bagus tu macam mana? Hi, macam mana? How? Where is the most smartest way? Apa orang? Tak apalah, dia untuk recording lah. The smartest way is somewhere lah. You have to put it somewhere. So the smartest way is when you don't have to resolve all the forces. The smartest way would be sini lah. Minus, go up. Click on motor. Click on linear motor. Paling efektif sekali kat sini lah, kat bawah ni. Flip it. Right? Instead of constant speed, you want to change to distance. Berapa distance? Tengoklah balik sini. 1581 tolak 6618. Berapa? 1581. Or 6618 minus 1581. 5037. Saya letak 5000 lah. Ini dapat 5037. So kamu tak payahlah skema sangat bila design tau. 5037. Letaklah berapa nak letak, 5000 ke. Tak payah skema sangat kadang-kadang. Nobody design things like this thing can lift up to 5003 mm. Nobody put specs like this, right? People would put specs like 5000 mm, 5 meter ke, itulah lebih kurang. Okay, so let's say I want to test this thing to be able to move 5000 lah mm in 5 second. Cepat sangat kot. Maybe 10 second kah, 10 second. And then I click on accept. This one I change lah. Key point time change to 10. That is the most effective lah. Tapi dia tak boleh redesign kan, because your hydraulic cylinder is not that long. But you just wanna find basic one lah. Nak test dulu whether your analysis is correct or not. So if you kenapa dia tinggi ya? Sudah accept ni. Simulation cannot continue lah. Kenapa dia naik atas? Kenapa dia tak turun bawah sekali? Did I not capture it properly? Patutnya dia akan capture ni kan. Create new motion study. Dia dalam keadaan flat. I'm going to delete this one. Motion study 1. Do it again lah. Motion analysis. Put the force here. Reverse the force. Can't remember what it is. 2298 kilogram. 2298 times 9.81. Enter. Click on accept. And then I'm going to put a linear motor. Change to distance 5000 mm in 10 seconds. The best location is at the bottom here. Although it's not logical, we just want to test. Okay. Macam tu lah. Now you have to edit this key point time lah. Change to 10. You might want to save your work, right? Because if it crashes, it's gonna crash lah. So don't lose your data. I think currently it's at the bottom. Now I can click on calculate. So my platform is rising lah from the bottom to the maximum height in 10 seconds. It should stop just nice. See? It stopped just nice lah according to your calculation. And we have force at the bottom pushing down, and you have a linear motor pushing up. So now berapa power dia patutnya? Cuba kira force. Force patut berapa tekan ni. Calculate force. Motor force. Magnitude pun tak apa. Where is my linear motor? 22743. Is it logical? 22743. 22743 bahagi 9.81. Yeah, quite logical. Original force. Nampak tak? Kau saya cakap seorang-seorang. Nampak dah pergi mana dah?
Ada Telegram.
Remember 2300 kilo convert kan? How many Newton? 2300 kali 9.81. 22563 22563 Newton. Roughly lah kan, 2300 kilo hampa nak angkat kan. Ni kan berat dia, mg sama dengan 22563 Newton. So when we analyze, we got it about 22743. So when we analyze, right, the data, what is going on? You got something like this, right? So the value here is the value there is 22743. 22743 Newton. So ini berat dia. This is what you get. So paling susah dekat the most bottom position lah, paling susah. So if you get something like this is logical lah. First you want to test whether your analysis is correct or not. So you might want to do something like this lah. Make sure your analysis is logical. So obviously nobody has a very long hydraulic cylinder. No way. Right? If you look at your hydraulic cylinder, you've got a lot of choices lah, but nothing that long. So you have to figure out lah which location is the best. So let's say if I were to change, right? Currently my linear motor is there. I want to edit this feature. Saya nak edit apa? Ni. Location ni no. Change this one. Instead of there, I want to put here. Boleh tak? I want to put hydraulic cylinder here. But I don't want in this direction lah kan. It cannot move lah like that. This one, I want to choose this line lah. Baru dia pergi arrow macam tu. Boleh tak? Change to accept. Okay, remember, kalau hampa bawa sini kan, dia patah balik lah kan. Dia reset balik. Macam tu. Remember this force? That one is okay. Click on linear motor. Macam ni, dia kena macam ni. Your linear motor has to work like this. Remember this arrow? If you forget, now I edit here. So now just imagine I have a hydraulic cylinder here. So I'm pushing this linkage. Okay. So, but in this case, I cannot push 5,000 lah, right? If I push 5,000, it's crazy already. How much? How long should I push? Depends on this length lah. This platform length. Tak apa, accept dulu. Later on we'll edit. So let's say choose evaluate measure center point to this one. It's about this much lah. Dia boleh gerak 940 je. Kalau letak 5,000 habis lah, meletup lah. So put your linear motor, in my case 940 mm. Do something like that lah. Okay, I'm going to turn it on again. I have a linear motor. So linear motor is simulating a hydraulic cylinder. Push to the right hand side. So if I click here, and then let's analyze. You can see my force pushing to the left, but my platform is going up and up, and then it will stop lah. Terlebih ke tu? Just nice lah, tak terlebih pun. Just nice. Okay, if I run again, not run rerun the simulation, and if I highlight both things, you can see lah those things. So now, cuba ke agak-agak, berapa force kita buat? I don't have to reselect kan. Result dah ada dekat sini. Click on results here. Click show plot. Oh tu dia. What happened? Just now berapa tadi? Just now we got about. Where is my mouse? Oops. Alternate tab. Right? Just now 22,000 kan? 22,743 Newton kan? Sekarang apa sudah jadi? So now it is banyak gila. 1 million? Seriously? Kenapa teruk sangat Sebab dia rendah sangat ni Too not effective. Too ineffective. I'm not saying that you should believe this data, but if it goes too much, there's probably something there. Oh, this thing is dark. Oh, habis semua. Never mind. I'll pull this one. So dia dalam keadaan flat macam ni tau. So it becomes very hard. Very hard to push. That's why it's like that. Kalau dia dalam keadaan open sikit kan, dia still okay lah. If it's bottom flat like this, it is some sort of like kind of lock. In order for the motion to move, it becomes very hard lah. You can just imagine in reality lah what's happening. So definitely this is the worst location lah. The worst location. Just now we have force. Right, remember this is our platform. All platforms like that, got some opening. The best way is pure vertical. The worst way is this one lah. Pure horizontal. This is the worst. The worst way. So, what next? What can we do to try? So, that's the nice thing about having this tool for your analysis lah. You can try before you finalize your design. So probably it's not a good way lah to have the hydraulic cylinder here. So the hydraulic cylinder should probably be kat mana? Kamu kena cari sendirilah. I cannot tell you where lah. You have to analyze. How do you want to analyze? You can try already, right? Go to here. No. Go to your linear motor. Edit feature. Where do you want to put it? This one currently is at the bottom, right? Now change. Maybe I want to put it here. Right? I don't want to put it in that direction. I can change direction. Click here. Choose a vertical line. And then I can flip it. There you go. Update. Yes. Update. Dalam keadaan ni lah. Oh, tidak. Dia sudah berubah ni. Remember? Think just now I should not put this. It should be at the bottom. Remember? Should be at the bottom. Force is good. Linear motor. Edit feature. Change to here kah? Oh, do it again. Linear motor, edit feature, change back to here. Okay. Now if I run it, but I cannot put 940 lah. Remember this one. This length cannot be lah 940. If I put 940, it's not enough lah. It's going to rise 940, then it's going to stop lah. Pop. Tinggi juga no 140 lah. Oh betul lah, this length kind of long lah, but still not all the way up, right? If you wanna put it all the way up, you have to ini kot lah ke ini. All the way up. There you go. Measure. Click on measure this line to the bottom lah, I suppose To the bottom. Dapat berapa? 110, no 1909. And then I go back to this one, I suppress, and then this one I activate. Teruk sangat ni. Suppress lah. Habis hancur. Okay, it's good. Okay. Somewhere like that lah. 1909 minus lah, kena minus this one to the datum, this reference lah. What is the length? Measure this one to platform 267. So minus lah, just now you get what is the measurement. Berapa? 1909 minus 267. 267. Berapa? 1909 minus 267, around 1.6 meter. 1600 mm. That is the travel. Keep for this motor lah. Hopefully you guys can see things like this. Right click, edit feature. So 940 is not enough, it's about 1600. And then I can recalculate lah from the bottom. So if I put a hydraulic cylinder here, what is it? The travel is about that much lah. So now you can check back, what is the motor force? Show plot. There you go, it's not so high anymore, right? So you can try lah a few places. Where do you think is the best location to put the hydraulic cylinder? Okay, part 1. I guess we need a new part lah. I think this is enough for the time being Next part is kind of long Next part, you guys have to go here, SMC catalog. Saya rasa ni next class lah. Banyak sangat ni. But you can explore What I want you guys to do is to go to here, SMC catalog. You can browse through, there's a lot of catalog. You can refresh back lah what you learn in your pneumatic hydraulics. Anybody remember Now is the time for you to buy.
10 tahun dah.
10 tahun dah credit transfer
Transfer.
So nanti kerja kamu kena tengok a lot of specification ni. Nominal pressure 10 megapascal. Kamu perlu berapa Newton force tadi? In your last analysis, let's say I choose this one 68,000 Newton. Maksudnya 68 kN lah, 68 kilo Newton. So 68 kilo Newton, nak pilih mana satu? Ini berapa dia punya force dia boleh terima? Macam mana nak baca? Do you know how to read?
Bukan maximum allowable pressure ke?
Pressure, yes, but then you have to convert it into force by using the cross section. Remember? Pressure sama dengan force bahagi area kan? So if you have the pressure and you have the cross section area, you can convert to force lah. So you have to select which one is the best one. Dah select, kena import pula dia punya cat data. You can go here. This one we are using SMC punya manufacturer lah. If you click here, kena carilah. Mana nak cari? Hydraulic equipment, hydraulic cylinder. Which one is suitable for your case? JIS stands for, I think, Japan International Standard lah. CHA tie rod. Dia ada tie rod. Maybe this one.
Tie rod.
Series compatible. Double acting single rod. Dia ada bagi dah ni. You can even see it in 3D. Benda ni boleh download dia punya CAD data dia, lepas tu masuk. Kamu kena merge lah. You have to assembly back with your current ni. You have to marry it together. Banyak kerja kan ni. Kamu kena buat plate. Remember, you cannot just assemble like that, right? There's got to be some sort of bracket lah. Memang banyak kerja lah. We need more time lah. Okay, let's explore. This one is mounting style is basic type. Kalau tukar single clevis, apa jadi? Update preview. See ni. Sekarang sudah ada clevis. Okay, this is a mounting point lah. If you change to double clevis, update the preview. Dah ada dua bracket, dua clevis. Clevis ni is some sort of like a flange. You can even generate PDF, you can even generate CAD. This one you decide lah which one. Double better, I think. It can withstand a lot more shear load. Without magnet. What else? Without rod boot. Cushion both sides. Thread on. Bore size 40mm. Kita bagi besar sikit, paling tinggi. That's why it takes some time for you guys to explore. Ini paling besar lah dia punya diameter dia, 160mm, 16cm lah, besar sangat kot kan. That's what I want you guys to explore lah. Learning how to this is the stroke, remember? Just now what is the stroke that I put? Can't remember already. Siapa ingat? This stroke linear motor edit feature 1600mm kan. So the same thing applies here lah. Dia paling tinggi ni je, 1500mm je plunger dia. If I update lah. This is the longest plunger punya length. Tu dia 1500mm je. So maybe I should follow the standard part that I have 1500mm. That's the thing lah. I want you guys to explore and generate CAD. Ini dah ada dah. you can try lah using the thing. The generate CAD. I think it's going to ask you lah what format. Zip file. Let's check it out. SolidWorks, dia bagi SolidWorks terus. Senang cerita. 7-zip, extract to here. Dia dah bagi SolidWorks punya part format. Kalau SolidWorks kan, kamu nak merge kan, kamu drag ni masuk SolidWorks terus. Pergi sini. Drag and drop. Yeah, you can even go to your assembly Where is your assembly Here. Assembly mode. Pergi ke file tu kan. Drag the assembly file. Drag it here. Rebuild this document. Punyalah senang. I've got my hydraulic cylinder. Yang ni fix kot. Tu dia tak boleh gerak tu. Where is my hydraulic cylinder? Ini CHD ni. Can you move this thing? Can lah. You can move. Does this thing have some sort of... Explore lah kejap. Open up this thing. This is the part. Oh, ni bukan assembly I guess you better open up the assembly lah. Assembly is like this. This thing can move? Cannot Dia tak assemble properly Dia just bubuh je lah. Kamu kena assemble lain lah. But I guess they give you a proper one lah. Benda-benda yang penting dia bagi. Ini sebab dia fixkan semua kan. Float balik. Because I expert already right. Float balik. Alamak, ni bergerak dah. Macam tu lah. Don't follow me Nanti dia update kat sini pula jenuh. Habis berkecai lah saya punya ni. See? Dia dah update So okay, remember this is the flange. So you still have a long way to go lah. So do it slowly and slowly. We are trying to merge a cylinder. So is there any limitation for you guys to do this? No, there's no limitation. If you want to put 2 cylinder, go ahead. If you want to put 1 single cylinder, that's fine. But do at a few locations lah, so you get a hang of it and to know which one is the best one. And if you look at how this thing is being done you can see lah how many cylinder they use. Kita tengok kita punya ni. Go here. Ini pun dah ada kan jawapan kan. See one of the ways that they put 1 cylinder here, 1 cylinder here. How do they decide? This is the thing lah that they analyze, they do. But the thing is, the point that we're making today is you can analyze your model easily and make the best decision lah, moving on. So let's go back here. Where are we now? We're here, right? Design. Ini apa hal ni? 20 mm per second. Okay, ni check it out Check this out. Design and select a suitable hydraulic lifting cylinder. Size, location, use manufacturer data. Dah kamu ada hydraulic cylinder, then you can redefine back lah. This is the one you can do lah. Berapa height dia boleh naik tinggi. So you can also find out lah what is the force for 500 kg payload and what is the required power for 500 kg payload. So things like this would have been so hard to calculate lah if you calculate manually. Now you can merge your design.
So nak tanya kan, ini kita cerita pasal tu. Kalau contoh kan selalu kan macam design, orang designer dia akan dua jenis calculation. Satu calculation apa tu?
Manual.
Calculation manual dengan satu lagi calculation guna CAD.
Yes.
Kan, jadi kenapa diorang buat dua-dua? Kenapa diorang tak tumpu pada CAD ni?
Tak boleh, bahaya CAD. You can make a simple mistake. For example, plain carbon steel kamu tukar jadi a different material. So weight dia dah lari dah. So very dangerous lah. You have to do two things.
Contohnya macam calculation tu dia tumpu pada satu tempat je.
Sebab manual calculation is very limited lah on the things that you can do. That's why in the beginning of the study saya buat force kat bawah ni kan. I have a simple force analysis that I did, and screen white. And the beginning of the analysis, I analyze this only. I force ini berapa? I think this one was like 2300 Newton kot. I tested this one. And then I get a reasonable result lah. I think this one we got, I think about 27,000 kot. This is reasonable accuracy lah. It doesn't go crazy lah, this one. Because this one is linear. Just now we get a crazy result when we are doing this one, right? Kita nak there's a force going down. Kita nak tolak force ni atas, but we are giving it a horizontal force. Ini yang dapat dekat 1 million tu, which is ridiculous lah. This is the worst thing that you can do when you're designing this lah. So that's the thing. Always manual check. Always do that. Okay, so for this week you can do this up to this level. Explore the interferences problem, and then you can even explore here all these catalogs. Learn lah how to write, how to read technical data. Sebab hampa nak beli mendatang ni kan, kalau beli silap dah rugi, banyak rugi lah. Kalau tersilap beli, order tersilap, wrongly used, then huge problem. Read lah SMC catalog. Maybe you want to design something with let's say screen. Full screen first. Screen, white screen. Maybe you want to design a hydraulic cylinder. Maybe at the back here you want a flange like that. Maybe this one you've got a plunger, and you want this ring circular item. What is this called? Since maybe this one can merge in your design properly. Ini kan nak pasang dekat base kan? Your base is flat like this only. How to pasang? You guys have to design here some sort of bracket. Okay kah? I guess cannot do too much otherwise you'll be lost. We're up until here.
Memang minggu depan lah.
So minggu depan when you come back, you should select already lah your hydraulic cylinder. Kan kat sini kan, kalau kamu pasang kat sini, kamu nak buat apa? Flange kah? Dua plate macam tu kah? So kalau kamu buat plate ni kan, berapa tebal plate ni? Kena buat structural analysis pula lah. Remember? Lepas tu ni ada remember your shear load. How do you design all these plates? Ni nak tebal berapa? Ni tebal berapa? That's the things that you have to decide lah. Ini kita buat macam ni je kan. Kita bukan buat sampai macam ni kan. Ini ada roda lah ni. Susah ni. There's a lot of things involved lah. I think one engineer cannot do this one. This one, I think 2 engineer do. This one, I think another 2 guy. Bottom.
Kalau macam tu kereta pun macam case apa tu? Dia pun bukan case apa tu? Macam body dia pun
Ya, memang. Kalau kamu a car body kan, semua part ramai orang buat. Pintu, so many designer lah. Door handle, another guy. Door panel, dia punya interior pun macam orang lain. Sebab tu, that's why if you take previous designs or reuse back something that is proven already, that's easiest way lah. Sebab detail design memang ramai lah orang kena buat kerja. Styling dia tu susah dekat awal-awal je lah. Bila styling tu dah settle, pass dekat mechanical design engineers, nak buat benda ni lah macam-macam. Tu tedious lah. So check this out. SMC Web Assistants. Okay, so that's all for this week. We'll see you guys next Monday dekat lab. Dan boleh tengok minggu depan. You can see you guys physically. Kita boleh assemble everything together and then it should be fine lah. We'll do some manual calculation also. Okay, that's all today.
Saya dah boleh tutup recording lah.